Hi, I'm Miss Hearn. Let's get started. In this video, we're going to talk about rationalizing denominators. I'm making this video for a calculus course because some of the answers we get will involve radical expressions, and we need to make sure they're in simplified form. But this is a topic that we cover in pre-calculus and algebra. It comes up a lot, even trigonometry. So let's go ahead and first of all understand what we mean by getting a radical in simplified form. So in order for a radical expression to be in simplified form, it cannot contain any radicals in the denominator or fractions under the radicals. So each one of these three expressions has one of those characteristics. A and C have radicals in the denominator, and B has a fraction under the radical. So in each case, we're going to use a technique called rationalizing the denominator to get it into the form that we like to have our answers in. So let's start with A. We have 2 over the 5th root of 3. The procedure that we're going to use is to multiply the expression by 1 in a special way. We're going to multiply by the 5th root of something in both the top and the bottom. The challenging part about this is you have to think about what you want to end up with and then work backwards to determine how to do that. So what I mean by that is we would really like in our denominator to end up with the 5th root of 3 to the 5th. That way we can cancel the 5th root and the 5th power and end up with just a 3 in our denominator. That's what we want to happen. Now we got to think about how we can make that happen. So we know that we're going to multiply the 5th root of 3 by the 5th root of 3 to some power. Now remember, the 5th root of 3 is really the 5th root of 3 to the 1st power. Even though it's not written, there is a power of 1 there. And when you multiply like bases, you add the exponents. So we're looking for a power of 3 such that 1 plus that power is equal to 5. So that power must be a 4 in order to make that happen, because 1 plus 4 is equal to 5. So let's multiply by the 5th root of 3 to the 4th over the 5th root of 3 to the 4th. Again, we're just multiplying by 1 that way, so we're not changing the value of the expression, but we're going to get a format that we like. Multiplying straight across, as we do with fractions, we would get 2 times the 5th root of 3 to the 4th, which is 81, and that can't be simplified because a 4th power is smaller than a 5th. And then in the denominator, we're going to cancel out the 5th root and the 5th power, so we're just left with a 3. And I'm going to write 2 times the 5th root of 81 in the numerator. This is the standard format that we would like to see our answer written in. For part B, we're looking at an index of 7, and we have a fraction of 3/2 under the radical. We do not like to have a fraction under the radical, but there's a very easy way to fix that. We're going to split it up into the 7th root of 3 over the 7th root of 2. But we don't like to have a radical in the denominator either, so the next step will be to rationalize. Once again, we know that we're going to be multiplying by 1 in a special way. We also know it's going to be the 7th root over the 7th root. But of what? So we would like to get, when we multiply this out, the 7th root of 2 to the 7th power. So using what we want to happen, we work backwards and say, what would we have to multiply 2 to the 1st by? What power of 2 in order to get 2 to the 7th? Well, we would need 1 plus this power to equal 7, because when you multiply like bases, you add the exponents. So the only way that's going to happen is if we have a power of 6. So we'll multiply by the 7th root of 2 to the 6th over the 7th root of 2 to the 6th. This will give us what we want in the denominator. Now let's see what's happening in the numerator. We're going to have the 7th root of 3 times 2 to the 6th. In the denominator, the 7th root of the 7th power is just going to leave the radicand 2. And in the numerator, we will have 2 to the 6th power, which is 64 times 3 equals 192 under our radical. By the way, I know that can't be simplified, that 7th root of 192, because this is our prime factorization of 192, and you'll notice the powers are less than 7, so there's no way that we're going to have any perfect 7th powers going evenly into 192. So this is our final answer on this item. And for this last one, we have 1 over 25 to the 1/4 power, which is really a radical written in a sneaky way, right? The 1/4 power is really the 4th root of 25 to the 1st. Now, you might think that we're going to want to multiply by the 4th root of 25 to some power. And you could do that, but you would be working with larger numbers than necessary. Here's why. Unlike the previous two problems where the denominators had a radicand of which was a prime, 2 and 3. This is 25. This is not prime. So before you actually decide what you're going to multiply by, let's go ahead and find the prime factorization of whatever the radicand is. So in this case, the prime factorization of 25 is 5 squared, and that will keep our numbers smaller. So now what I want is to multiply by the 4th root of something over the 4th root of something. But how do I decide what? Well, I want to end up with the 4th root of 5 to the 4th. Over here, we're going to multiply by 5 to some power such that 5 squared times 5 to that power equals 5 to the 4th. And that will only happen if the exponents add up to 4. Well, that means that we must use an exponent of 2. So we'll multiply by the 4th root of 5 squared over the 4th root of 5 squared. That will give us the denominator we want. In the numerator, we have 1 times the 4th root of 5 squared, which is just going to be the 4th root of 25. In the denominator, the power and the index cancel. So we have the 4th root of 25 over 5. And that is the simplified form of that expression. I hope you found this video helpful. If you did, please remember to like it. That helps other students to find the video.